So I probably should have explained how we did the coral tablets as well. We had the acrylic discs, and what we had to do was, the corals are mounted onto the acrylic discs using super glue. So all of that stuff really does come into play because this method is so accurate. You really have to be careful about anything that can throw off the numbers. So we wanted to be accurate as possible in knowing what the contribution of the acrylic disc along with the super glue and the monofilament had on the weights we were getting. So we once the study was done, the corals had to be broken off of the tablets, and then we had to dissolve the tablets in dilute hydrochloric acid to get rid of any excess coral skeleton that would have still remained on the tablet. They were then dried and dry weighed, and based on the density of the acrylic that was used, we calculated out what the buoyant weight at each weighing would have been for the tablet, subtracted that from our total buoyant weight with the coral included, and then calculated our numbers from there. So we'll look at the results individually for the species. This Acropora species showed very, very little difference across the board, really. Even in the tank where I had the temperature issues, we've got a pretty similar growth rate. So didn't see really any difference, tiny significant difference, but probably not attributable to the suppressed strontium. So didn't see a whole lot of difference with those. And the same is true really for the other Acropora species that I looked at, the Boleta. We got very similar growth rates between the control tank and experimental 2, which these actually stayed at constant temperatures that were the same. So we can count that as a valid comparison. And at the same time, we've got this middle tank where I had the temperature issues, and the growth rate actually was significantly lower in that system. So the next species, the Seriatopora, grew really fast. It actually showed a pretty decent decrease in growth rate in the control compared to the experimental 2, which for our purposes, or for accuracy purposes, really we can only compare these two because we do know that temperature does play a role in the incorporation of strontium. We really can't, this system's really kind of been thrown out of the mix as far as I'm concerned in looking at accurate data. So if you look at these two, you can see there's a pretty decent decline in growth on that species. And then the same is true for the Monophora digitata. So we saw actually an increase in growth with the warmer temperature on this species, and a significant decrease in growth at the same temperature with suppressed strontium. So just to kind of recap that, both Acropora species are seemingly unaffected by the reduced available strontium, so really didn't see a whole lot of difference in growth rates between the Acropora species in both of the tanks. The S. hystrix and M. digitata showed a notable decline in growth, 9% and 12% respectively, when grown in saltwater with suppressed strontium, so less than 1 milligram per liter. The Acropora boleta and the S. hystrix showed a drastic decrease in growth in system number 2. So those two corals specifically were obviously affected by the higher temperature that was present in that system. And then the Monophora digitata showed an increased growth at a higher temperature even with the suppressed strontium. And the A. youngii does not appear to be affected by temperature, so it stayed pretty flat across the board. So it doesn't seem to be affected by the temperature nor by the strontium. So the whole temperature aspect was not something I had anticipated or expected to see results on. I didn't expect for that to happen, obviously, but kind of produced some interesting data as well. So the conclusion that I've come to, just based on looking at this and comparing the control tank to the experimental tank 2, is that there appear to be a species-specific decline in growth rate when grown in saltwater with less than 1 milligram per liter of strontium present. Future considerations, which I would like to continue to look at strontium a little bit deeper. I think it's, could probably produce some pretty important information for us. One thing I would like to address is it possible that the combination of a temperature increase and depressed strontium can significantly impact the growth rates of certain species? Because we did see some results that might be consistent with that, so it might be something worth taking a look at in the future. And this is just a list of the references that I used for the study. And that is all I have for you. Does anybody have any questions?
Yeah.
Back. You could definitely do studies on that. That's been looked at pretty well as far as how light impacts coral calcification rates. Actually, there was a study that I read that looked at coral calcium-magnesium ratios and strontium and calcium ratios based on increasing light spectrum. And they found that magnesium ratios went up significantly with increased light, but strontium actually wasn't impacted by the increased light at all. Strontium ratios weren't. So sorry, go ahead.
Yeah, first of all, thank you so much. Yeah, we'll see some of our audience. Question, how do you think that publishing down below versus
Probably not very often. That's another thing that I'd like to look at in the future is I know there have been some other hobbyists out there and aquarists out there that have investigated a little bit into what do our strontium levels look like in our tank? How does our dosing schedule and our water change schedule and the products that we use impact that? And it wouldn't be a bad idea really to kind of start there and say, okay, this is what we see in a typical aquarium, and then this is what's worthwhile to look at. So I would think that most hobbyists are doing water changes probably pretty frequently, but who knows what their salt contains. You can't always predict what is in synthetic salt. So if you're doing water changes with synthetic salt, that is something to possibly consider as an issue. So.
I didn't see any error bars. Did you do these with this?
I have some other information on that, like doing as far as using the buoyant weight method and what the error deviation is there.
Well, I'm sure that there's very good decision information, but I just didn't know if dealing with the differences in salt versus are they robust to throwing out?
Sorry, what was the last?
Are they robust to throwing out big points or?
I probably have to take a look a little bit longer at it. I kind of just finished this up, and so this is what I have for the time being. But definitely, hopefully, we'll have some information related to that at some point soon.
Me. Any thoughts on the specific? So you started off by saying that there is a declining rate of strontium present in the coral, and so that suggests that there's an age component. Maybe did you give any thought to the age of the particular corals that you used to see if maybe they were at an earlier rate where absorption?
I didn't say anything about. He was saying that I said that there was evidence of a declining rate of strontium in the corals, but I didn't say that.
Oh, I thought that's what you had said in the beginning. That
Gotcha. No, what I was saying is that there are species that have been studied, and they studied different portions of the same coral and found that at different parts of the coral where they calcify at different rates, the strontium levels can be different. And so in the apex of a coral, for instance, it grows faster.
Okay.
So they actually
not to be
saw
correlated
lower
with
strontium.
age.
Right. No.
Okay.
Yes.
This is Friday and this is G.
Yeah. It was actually just pure strontium chloride. It's like 99.9% strontium chloride. We do have a strontium chloride product, yeah. Anybody else? Thank you.